All right, so the next question here is looking at a work rate problem. So we have if Barbara were to paint her living room alone, it would take 5 hours. Her sister Terry could do the job in 7 hours. So how many hours would it take them working together? All right, so again, the main formula we have is the amount of work done is equal to the rate at which they can do the work multiplied by the time, so how long they are working. So in this case, they have to paint one room, so the amount of work done is going to be 1. And then the rates, so Barbara can paint the room in 5 hours. That means she can paint 1/5 of the room per hour. So just take 1 over the time there. And then Terry can paint the room in 7 hours. So that means that she can paint 1/7 of the room per hour. So then together, they can paint the room in 1/5 plus 1/7 per hour there. All right, and then we need to figure out the time. So this is the equation that we're trying to solve here. All right, so in this case, when we're adding two fractions, again, when we add or subtract two fractions, we need to have a common denominator. So in this case, the common denominator is going to be 35. So 1/5, we can write that as over 35, so you need to take 5 times 7. So again, we need to take the top times that same number. So in this case, 1/5 is going to be 7/35. And then 1/7. So again, we can take the bottom times 5. So again, we need to take the top times that same number. So when we take 1 times 5, we end up with 5. So then we can just add straight across. So we have 7 plus 5 is going to be 12/35. So you have 1 equals 12/35 times t. All right. So then to get t by itself, we can just multiply both sides by the reciprocal. So we can multiply by 35 over 12 times 35 over 12. And we end up with t equals 35 over 12 hours. All right. And I'm looking, trying to see if there's anything that goes into both those. In this case, there's nothing that goes into both of them. So in this case, it says express your answer as a fraction. So we just have 35 twelfths. All right. So the next one here asks us to change the following expression to an equivalent expression in exponential notation. So we got 15 here. All right. So we have the 9th root of 5 squared. There we go. So you have the 9th root of 5 squared. All right, so again, this is your index. This is your exponent here. So to write this as an exponent, so it's going to be a fractional exponent, so we have a root. And then the bottom of your fraction is the index of your root. So in this case, the bottom of my fraction is going to be 9. And the top is going to be your exponent. So the numerator of your fractional exponent is going to be the exponent in the original here. So in this case, that's going to be 2. Why is it not liking that? All right, give it a wild focus there. All right, so we end up with 5 to the 2/9. All right, so the next one here is asking us to solve a quadratic equation. And again, I don't care if you use the square root method exactly, but in this case, it does lend itself to the square root method. So most of the time, if it tells you to use a specific method, most of the time the reason it's doing that is because, again, that's probably the easiest method to use. So we have 8x plus 20 squared equals 50. All right, So yeah, so again we have something involving our variable squared equaling a constant value. So again, that means the square root method kind of lends itself to these types of questions. So yeah, so again we're just going to take the square root of both sides. And again, when we do that, we have to account for the plus and minus square root there. So here, a square root and the square root are going to cancel out. So you end up with 8x plus 20. All right, I'm just going to go ahead and simplify this guy here. So yeah, so perfect square that goes into 50, so 25 goes into 50. So you can write square root of 50 as square root of 25 times the square root of 2, which the square root of 25 is just going to be 5. So you have plus or minus 5 square root of 2. All right, and then again, we just want to get x by itself here. So we can start off, we can subtract a 20 from each side. Then we can divide everything by 8. So yeah, so we end up with x equals, most of the time we have the constant part first, and then we have the root part. I suppose technically they're both constants. The part that doesn't involve the root, and the part that does involve the square root there. Right? And in this case, 5 is prime, and 5 doesn't go into 8. So in this case, this is as simplified as we can get it. So this is going to be our answer here. All right. So we have negative 20 plus 5 square root of 2, 8. And then we have negative 20, negative 20 minus 5 square root of 2 over 8. Over 8. There we go. All right. All right, so then it says find the product of the binomial factor using the appropriate special product. Again, I don't care if you use this special product here. I often don't remember these special products either, so I don't really expect to force you guys to memorize them. So yeah, so again, when we square something, again, that just means we're multiplying it by itself. So x plus 2 squared is equal to x plus 2 times x plus 2. So again, we can just distribute everything through. So we have x times x is going to be x squared plus 2x plus 2x plus 4 for 2 times 2. So you end up with x squared plus 4x plus 4. All right. So next one here is looking at factoring. So you have 20x squared minus 21x minus 5. All right, so there aren't any common factors. I thought with the 5 there I could factor out a 5, but in this case 5 doesn't go into 21, so there's no common factors I can factor out. So yeah, so looking at this again, to figure out whether we can factor this or not, we can take 20 times negative 5, so that's going to be negative 100, and negative 21 here. So I'm looking for two things that multiply to get negative 100 and add to get negative 21. So we got negative 100. So yeah, so by pairs of factors, we got 101. We got 2 and 50. We got 4 and 25. And one has to be positive, one has to be negative. So we got negative 25 and 4, it looks like. All right, so yeah, so again, we're going to split up this negative 21 into negative 25 and positive 4. So you have 20x squared minus 25x plus 4x minus 5. And again, we're just going to factor each group here. So 20x squared minus 25x. So 5x goes in each of those. So we have 4x minus 5. And then here we already have 4x minus 5, so that's just going to be factor out of 1 pretty much. And then again, we have a common factor of 4x minus 5 that shows up in each of those. So again, we can group up what's inside the parentheses, and then group what's outside the parentheses. And again, if you're ever curious as to whether you have the right factoring or not, again, you should be able to multiply these out, and you should be able to get what your original expression is, which in this case, it does work out that way as well. All right, so we got 4x minus 5. I want to close the parentheses. Okay. Sometimes these programs are so annoying. All right. Plus 1. There we go. Yeah, whatever. All right. This is why it's handy to have a worksheet so that you can turn that in so that if you make a mistake when typing it out, I can see that you have the correct answer and I can give you credit for that. All right. So yeah, so here we have solved the following absolute value equation. So we got 2x plus 5, absolute value, minus 6 equals 0. All right, this is 19. All right, so the absolute value of 2x plus 5 minus 6 equals 0. So again, the first step is to get the absolute value all by itself. So we can add a 6 to each side. So you have an absolute value of 2x plus 5 equals 6. All right, so if this number is less than 0, then you're going to have no solution. If this number equals 0, you're going to have one solution. If this number is bigger than 0, you're going to have two solutions. So in this case, since my constant is bigger than 0 here, I'm going to have two solutions. All right, and again, those solutions are, so we can split this up into two separate equations here. So we have 2x plus 5 could equal positive 6, or 2x plus 5 could equal negative 6. Because again, the absolute value of negative 6 is also going to be positive 6. All right. So yeah, so then we can just subtract the 5 from each side. So we're just solving the linear equation here. So you have 2x equals 1, and 2x equals negative 11. And then we just divide both sides by 2. So you have x equals 1/2 and negative 11 over 2. All right. All right. So the next one here. So you have negative 4 to the 4th. All right. So yeah, so again, the main thing to keep in mind here is order of operations. So again, we do the exponents first before we do the multiplication and division. So if this was in parentheses, we'd have negative 4 times negative 4 times negative 4 times negative 4 times negative 4. I think I only said 3 there. But since this isn't in parentheses, we're going to do 4 to the 4th first, and then we're going to apply the negative sign at the end there. All right. So yeah, so 4 to the 4th, so 4, 16, 64, 256. So you have negative 256. Is going to be my final answer there. All right, so the next one here. So solving, again, another quadratic equation. So you have z squared plus 9z plus 20 equals 0. All right. So z squared plus 9z plus 20 equals 0. Again, it asks you to solve it by factoring, which again is kind of a hint that this will factor nicely. But again, you don't necessarily have to solve it by factoring. If you choose to, you can use the quadratic formula. But again, in this case, I think it might be a little bit more work and take a little bit longer. Because, yeah, looking at this, we have a leading coefficient of 1. So we're just looking for two things that multiply to get 20 and add to get 9, which would be plus 5 and plus 4. All right, and again, you just set each factor equals 0. So we end up with z equals negative 5 and negative 4. All right, so the next one here is looking at solving a rational equation here. So we have 2y plus 6 over 5 minus 1/10 equals negative 11y minus 4 over 10. All right. So yeah, so again, generally my first step is to get rid of the denominators if I can. So in this case, we're looking for something that 5 and 10 both go into. In that case, that's 10. So I'm just going to multiply everything by 10 all the way through. So here the 10 and the 5 will cancel out, so 5 goes into 10 twice. Here the 10s will just straight up cancel out. And here the 10s will just straight up cancel out there. So yeah, so now you guys distribute this 2 through. So we have 4y plus 12 minus 1 equals negative 11y minus 4. So we got 4y plus 11 equals negative 11y minus 4. All right, so then again, I want to get everything involved in my variable on one side, everything else on the other side. So I'm going to go ahead and add an 11y to each side. Subtracting 11 from each side here. So you have 4y plus 11y is 15y. And negative 4 minus 11 is negative 15. And then we divide both sides by 15. So you end up y equals negative 1. Which in this case, we don't have any variables in the denominator, so we don't have to worry about excluding anything. So in this case, there's just a single solution of negative 1. All right, next one here. So we are given factoring. So we got minus 9x plus 18. All right. So yeah, so again, we have a leading coefficient of 1. So in this case, again, we're just looking for two things that multiply to get 18, add to get negative 9. So in that case, that's going to be negative 6 and negative 3. Negative 6 plus a negative 3 gets me negative 9. Negative 6 times a negative 3 gets me positive 18. So that would be my factored form there. Nope. Ah. All right, so the next one says simplify the following expression, writing your answer with only positive exponents. So you have 1 over 6x to the negative 3. All right, so again, we want to write this as positive exponents. So again, you can move one of your, or in this case, both of your terms. But in this case, this is 6 to the first, so this already has a positive exponent. So we don't want to mess with the 6 at all. But you can move a term to either the top or bottom of your fraction, and again, you just change this on your exponent. So in this case, we're going to move the x to the negative 3 up top. So that's going to become x to the positive 3. So you have x to the third over 6. All right. So next we're asked to solve this equation here. So yeah, so again, when we have a factor, it's a zero factor property, so you can only use a zero factor property if your factors multiply to get 0. So you can't set each of these equal to 4 and say, oh, well, x equals 3. You can only set these factors equal to 0 when it equals 0 here. All right. So yeah, so in this case, we do got to rewrite this in standard form because we got to figure out how to factor it when it equals 0 here. So yeah, so expanding this out gets us x squared plus 1x plus 1x. So that's going to be plus 2x plus 1 equals 4. So I'm just going to subtract the 4 from each side. So we have x squared plus 2x minus 3 equals 0. All right, so now I want to factor this guy. So you have x and x. So I'm looking for two things that multiply to get negative 3, add to get positive 2. So that would be positive 3 and negative 1. So yeah, so then we have equals 0. Again, since we have it equaling the product equaling 0, then we can set each factor equal to 0. So you end up with x equals negative 3 and x equals positive 1. Yep. All right. All right, so the next one's asked us to solve this using the quadratic formula. Again, I don't really care which method you use. If you can find the factors that make this factor nicely, you can go ahead and use factoring if you want. So yeah, so when we multiply this out, we get negative 15, which are 1 and 15, and 3 and 5, which neither of those get us a negative 3 there. So yeah, so I don't think this ends up factoring nicely. All right, so again, we just need to know our ABCs. So again, A is whatever your leading coefficient is. So it's the number in front there. B is going to be your middle coefficient, or whatever is in front of your variable raised to the first power. And C is going to be, again, your constant term, so negative 3 in this case as well. All right, so then we have y equals negative b, so we have negative 3 plus or minus the square root of b squared, so we got negative 3 squared, and we do want to include that negative 3 in parentheses here, because as I talked about earlier, if you don't have the parentheses, it would be negative 9, but since we do have the parentheses, it is going to be positive 9. So we do end up with different answers if you have a negative number there. All right, so then we have minus 4 times a, which is 5, times c, which is negative 3 again, all over 2 times a, which again is 5. All right, so yeah, so we have negative 3, so that's going to be positive 3, plus or minus. We get 9. This would be plus 4 times 5 is 20, 60 over 10. So you end up with 3 plus or minus the square root of 69 over 10. Which 69, I don't think there's any perfect squares that go into that. So yeah, so that's going to be our final answer there. So so we got 3 plus square root of 69 over 10. Three minus square root of 69 over 10. So next we have simplifying a cubed root here. All right, so again, just like with the square root, we can start off by separating all these out. So you have the cubed root of negative 125, cubed root of x to the 6th, and the cubed root of y to the 12th. So the cubed root of negative 125, so that's going to be negative 5. And then here the cubed root of x to the 6th, again, we can write this as a fractional exponent. So we have x to the 6 over 3. And here we can write this as a fractional exponent as well. So we have y to the 12 over 3. Which then we can simplify each of these. So 6 over 3 is just 2. So we have negative 5 x squared. And then 12 over 3 is going to be 4. So we have y to the 4th. So we got negative 5 x squared, y to the 4th. All right. So the next one here, see they have the area is given by the polynomial function. And b equals b squared plus 10b plus 21. And we have the width is b plus 3. And we're asked to find the length. All right. So again, area of a rectangle is length times width. So to start off, we're just going to factor this guy. So yeah, so we have a, b. So yeah, so in this case, we have b and b. So in this case, I'm looking for two things that multiply to get 21 and add to get 10. In this case, that would be 3 and 7. So when I factor it out, we have b plus 3 and b plus 7. So the width is b plus 3. And again, the area is width times length, or length times width. So that means my length is just going to be b plus 7. All right. All right. All right, so we want to solve this equation for a. So we want to get a by itself here. So first, I want to get everything involving my variable that I want to solve for on one side, everything else over on the other side. So here you can subtract v naught squared from each side. This is how you can find your final velocity if you have an initial velocity and an acceleration and change of position. In case you were curious, that's where this formula comes from. So yes, we have v squared minus v naught squared equals 2ax. All right, and then we want to get a by itself, so we can just divide everything by 2x. So yeah, so we end up with a equals v squared minus v naught squared over 2x. Okay. All right. Minus. Okay. B. What? Why won't you let me do that? What? Yes, I do need that. This is. Okay. Maybe it wants it factored. Use the key V naught from the keypad. Oh, there he is. Okay, that's annoying. All right. X. All right. All right. I think I might need a little bit. Maybe not. All right. So you have the fourth root of 6z minus 2 equals 2. All right. So again, to solve a radical equation, you can just raise each side to the power of whatever your index is. So in this case, my index is 4, so I'm just going to raise each side to the fourth power. And again, the fourth power and the fourth root are going to cancel out, so I'm just going to have 6z minus 2 on this side, and then 2 to the fourth. So we got 2, 2 squared is 4, 4 times 2 is 8, 8 times 2 is 16. All right. So then we need to add a 2 to each side. So you have 6z equals 18, and divide by 6. We end up with z equals 3. All right. And yeah, when I plug this back in, 6 times 3 is 18, minus 2 is 16. Fourth root of 16 is indeed 2. So z is going to equal 3. All right. All right. So next we're asked to factor this trinomial. All right. So yeah, so looking at this, we have 2 goes in every single one of these. In fact, negative 2 does. So I'm going to go ahead and factor out negative 2. And we don't have an x in my last one, but y to the third is also a common factor. So you have negative 2 y to the third. So then we're going to have x squared plus 6x plus 5. All right. And then we look at this guy. So this is a trinomial here. And 1 and 5 multiply together to get 5 and add to get 6. So we can factor this even further. So you have negative 2y to the third. You have x plus 1 and x plus 5. I know it thinks it's being helpful, but it automatically filling in parentheses kind of screws me up sometimes. All right. All right, so next here, so we're multiplying two rational expressions. Whoa. All right. Eesh. All right, so first we can factor these. So yeah, so looking at this, I think that I want to be able to cancel out the y minus 9. So I'm going to go ahead and try y minus 9. And in order to get negative 63 here, I need to have plus 7. And in order to get 5y squared here, this would be to be 5y. So if we take 5y, so that would be 5y squared plus 7y minus 45y, which would be negative 38y, minus 63. So it does work out. So yeah, so that one I kind of had to reverse engineer. Because again, I can kind of play the question and kind of say, okay, this is what the question really wants me to get at. So I kind of cheated a little bit there. Which again, you're allowed to do that too. All right, so yeah, so here I'm looking for two things that multiply to get positive 6, add to get negative 5. So that would be minus 2 and minus 3 over y minus 9. All right, and again, if we have any common factors, again, in either top and either bottom, you need one from each side. You can cancel it out. So you have y minus 9, y minus 9, y minus 3, y minus 3. So yeah, so what I'm left with is 5y plus 7 times y minus 2. And I'm fine if you leave it like that, if it doesn't count it right. Yeah, I mean, all right, simplify the following expression. All right, so you have 8 to the negative 2/3. I think you should be able to just enter this into a calculator. So yeah, so often, at least the calculators I know of, have the little caret symbol for the exponent, and then you do want to make sure that you include the negative 2/3 in parentheses. You should be able to do that, and it should give you an answer. Yeah, I'm not going to do that. So yeah, so this would be 1 over 8 to the positive 2/3, which we can write this as a radical. So this would be the cubed root of 8 squared. So you have 1 over that, which the cubed root of 8 is 2. So 2 squared is 4. So you end up with 1/4. All right. So next we're asked to simplify this exponential expression here. All right. So starting off with, again, if we have an exponential expression and we're multiplying, we can distribute the exponent through. So we're going to have y to the negative 2. And when we have an exponential expression that raised to a power, we multiply the exponents. So this would be y to the 3 times 2, so that would be y to the 6th, x to the 10th. And we can do a similar thing here. We can distribute the 3. And again, that means we're raising each of these to the third power. So we have 4 to the third, which is going to be 64. And then y cubed to the third is going to be y to the 3 times 3, so that's going to be y to the 9th. And we have x to the 6th. All right. So again, when we have two things that have the same base that we're multiplying, we add the exponents. So negative 2 plus 6 is going to be positive 4. All right. And we want positive exponents. So again, we want to subtract the smaller number from the bigger number. So I'm going to move this x to the 6th up, so that's going to be x to the negative 6th. I'm going to move this y to the 4th down, so that's going to be y to the negative 4th. So we're going to have x to the 4th on top because we have x to the 10th. So x to the 10 minus 6. And then we have 64, and then we have y to the 9 minus 4, so that would be y to the 5th. All right. All right, so the next one it says write a polynomial equation with integer coefficients that has the given roots. All right, so yeah, so when we factor it, we want to end up with these numbers as our solutions. So yeah, so in order to get x equals -3, that means that one of my factors has to be +3 because, again, when we set our factors equal to 0, we want to end up with those roots. And then to get +3, we do have, because yeah, again, when we set these equal to 0, we end up with x equals -3 and x equals +3. So in a nutshell, you want to take your constant terms and just change the signs from what they give you there. All right, and then we do need to expand this out. So we have x times x, so that's going to be x squared minus 3x plus 3x minus 9. Here the -3x and the plus 3x will cancel out. So we're going to be left with x squared minus 9 as our polynomial equation here. And it's equals 0. X squared minus 9 equals 0. All right. All right. So the next one here. All right. So we're going to solve this equation here. All right, so I would start off just by distributing things through. So again, simplifying on both sides of the equal sign. So we got -24w plus 24 equals 72 minus 12w. All right, and again, we want to get everything involving our variable on one side, everything else over on the other side. So I would go ahead and add 12w to each side. Subtract the 24 from each side. So -24w plus 12w is going to be -12w. And 72 minus 24 is going to be 48. And we're going to divide both sides by -12. So you end up with w equals 48 divided by -12, which would be -4. And again, if you're curious as to whether you have the right answer or not, you can always plug it back in. So yeah, so in this case, I'll go ahead and do that here. So we have 4 times -4, so that's going to be -16, minus 4 is going to be -20. So -6 times that is going to be positive 120. And then we have 6 minus a -4, so that's going to be 6 plus 4, so that would be 10, which 12 times 10 is also 120. All right. So the next one here, so we got 37. So it says complete with fact the trinomial if possible. So you have 16x squared minus 68x minus 60. All right. So looking at this, I think 4 goes into all of these. So we can factor out a 4 first. So you get 4x squared minus 17x minus 15. So yeah, so then it's just a matter of whether you can factor this guy. All So yeah, so in this case, we're looking for two things that multiply to get negative 60 and add to get negative 17. So in that case, that would be negative 20, positive 3. So yeah, so we're going to split up this negative 17x into both these guys. So you have 4, and we have 4x squared minus 20x plus 3x minus 15. And again, we're just going to factor each group. 4. And then we have 4x shows up in both of these. And we have x minus 5. And then here we have 3 shows up in each of these. And we have x minus 5. And again, we can group the things inside the parentheses and group the things outside the parentheses. So you have 4 times 4x plus 3 times x minus 5. 4 times 4x plus 3 and x minus 5. All right. So yeah, so you have x squared minus 289. All right. So yeah, so again, when you have a binomial, most of the time we're going to be utilizing the difference of squares. So you have x squared minus 289. So we got to figure out what 289 is as something squared. So to do that, you can just take the square root of 289, which I think gets you 17. 170. 70. Yep. Yep. All right. So yeah, so x squared minus 17 squared. All right, and again, when you have the difference of squares, you just have x plus 17, x minus 17. So you have this number plus this number, and then that number minus that number. So we have x plus 17, x minus 17. All right. Okay, home stretch. So we got y squared plus 5y minus 24 over y squared minus 8y plus 15. All right. So yeah, so again, to cancel, or to simplify, we can cancel out common factors. So the first thing we need to do is we need to factor this expression if we can. So yeah, so we are working for, so the top here, working for two things that multiply to get negative 24, add to get positive 5. So that's going to be y plus 8 and y minus 3. All right, and then for the bottom here, all right, so here we're looking for things that multiply to get 15, add to get negative 8. So that would be negative 5 and negative 3. All right, and then again, you can cancel out common factors. So yeah, so in this case, y minus 3 shows up in the top and bottom. So those can get canceled out. So our simplified form is y plus 8 over y minus 5. What? Okay, that's weird. All right. So yeah, so then the values that need to be excluded are the values that lead to 0 in the denominator. So in this case, even when you cancel out, you can't have 0 divided by 0 either. So yeah, so in this case, you're still going to need to exclude two values there. So the y equals 5 and y equals positive 3. All right. So yes, y cannot equal 5, and y can't equal 3. All right. All right. So next we are asked to solve this by factoring. Again, if it asks you to use a certain method, generally that means that that method is going to be the most straightforward, easiest one to use. But again, you don't necessarily have to use the exact method they say. I don't care. But in this case, it does factor nicely. So we're looking for two things that multiply to get 30, add to get 11. So that would be plus 5 and plus 6. And again, you just say each factor equal to 0, since again you have this whole thing equal 0. So you end up with y equals negative 5 and y equals negative 6. Negative 5 and negative 6. Okay. All right, so next we're asked to subtract these polynomials. So again, you just subtract like terms. So here you have x to the third, x to the third. Again, your like terms are terms that have the same variable raised to the same exponent. Here we have a constant term here and a constant term here. And here we have an x term and an x term. Right? So again, we can subtract the corresponding values. So here you have negative 8x to the third minus 8x to the third. So that's going to be negative 16x to the third. And I'm going to go ahead and write this in standard form, so descending powers of x. So here you have negative 5x minus a negative 9x. So again, when you subtract a negative, that's the same as adding the opposite. So that's the same as adding 9x in this case. So you have negative 5x plus 9x is going to be plus 4x. And then here we have 11 minus 13, so that's going to be minus 2. All right. So next it says solve this by factoring. So again, in order to use the factor property, it's a zero factor property actually. So again, it needs to equal 0. So to start off, we're going to subtract the 14 from each side to get this in standard form. So yeah, so we have y squared plus 5y minus 14 equals 0. All right, and then we can. So we're looking for two things that multiply to get negative 14, add to get 5. So that'd be positive 7 minus 2. And again, you can just set each factor equal to 0. So we have y equals negative 7 and positive 2. Yeah, negative 7 and positive 2. All right. So yeah, so this is just asking for it in standard form. So again, standard form means you have descending powers of x here. So you start with the highest exponent, and then you work your way down to the lowest. So in this case, my highest exponent is x to the 14th. So you have negative x to the 14th. And then my next highest is x to the 9th. So we have plus 7x to the 9th. And then we have x squared. So we have plus 2x squared. And then finally, we have our constant term. So we have plus 1. All right. And then it says to identify the degree. So the degree is just the largest exponent that you have represented. So in this case, this is a 14th degree. So the degree is 14. All right. And the leading coefficient is the number in front of your highest degree term. So yeah, so in this case, again, when there's no number explicitly given, we can kind of shove a 1 in there. So in this case, my leading coefficient is going to be -1. All right, so next we're looking at rationalize the denominator. So to rationalize the denominator, you're just going to multiply both sides. When you just have a single square root, you're just going to multiply both sides by that square root. So the top and bottom by the square root of 3x in this case. Because again, when you take a square root of something, multiply by the square root of that same thing, the square roots are going to negate each other, so they're going to cancel out. So we have 8 square root of 3x divided by 3x. Which if we can simplify this any further, like if we had any common factors between the 8 and the 3, we would do that. In this case, you can't, so that's going to be your simplified form. So you have 8 square root of 3x over 3x. All right. So the next one says, how long will it take for a ball dropped from a 484-foot building to hit the ground? All right, so again, we have our h is equal to h sub 0. Or I guess I'll stick with, again, the way they choose to represent it here. So you have -1/2 gt squared plus v naught t plus h naught. All right, so you want to figure out when it will hit the ground. So that's when h equals 0. And we have feet. So my g is going to be 32. It's dropped, so the initial velocity is going to be 0. And my initial height is going to be 484. So yes, 0 equals -16t squared plus 484. All right, so now I have something involving my variable squared and a constant value. So this kind of lends itself to the square root property. So yes, that's what I'm going to use. So I'm going to start off, I'm going to subtract the 484 from each side. Looking at it, probably should have added the 16t squared, but oh well. All right, so you have -484 equals -16t squared. Divide both sides by -16 to get just the squared part all by itself. So when I take 44 divided by 16, we end up with 30.25. All right. So yeah, so again, we can use the square root of both sides. And again, we're dealing with time here, so there's no mention of a time traveling device. So yeah, so in this case, we can kind of ignore the negative time. So yeah, so we just need to take square root of 30.25. We end up with 5.5 seconds. All right, next one here. So you have 2 trucks leave a warehouse at the same time. So one travels due east at an average speed of 57 miles per hour, and the other travels due west at an average speed of 62 miles per hour. So we have due east and 62, pH. And we want to figure out after how many hours will they be 773.5 miles apart. All right. So again, distance equals rate times time. Here the times are going to be the same. So we can just represent time by the variable t there. And we don't have to worry about which specific one we're looking at because, again, the times are going to be the same for both of them. All right, so yeah, so we just want the distances to add together to get 773. So yeah, so we have 62 times t plus 57 times t. So that represents the distances of each of these cars, the 62 mile per hour and the 57 mile per hour respectively here. And we want those distances to add together to get 773.5. All right. So yeah, so when we combine like terms here, so we got 62 plus 57, so that'd be 119 times t equals 773.5. So we can divide both sides by 119. So you have t equals 773.5 divided by 119, 6.5 hours. All right. All right, so next we're asked to factor these. So we have x squared plus 5x minus 6. So yeah, so in this case, again, I'm looking for two things that multiply to get negative 6, add to get positive 5. So that would be plus 6 minus 1. 6, x minus 1. All right, so yep, next we're asked to simplify the following expression here. All right. So yeah, so again, start off, we need to factor the top and bottom here. So yeah, so here we're looking for two things that multiply to get 70 and add to get 17. So in that case, that would be 10 and 7. All right, and then on the bottom here, we have a y shows up in each of those, so we can factor y out from the right off the bat. So we got y squared plus 3y minus 28. All right, and then here to factor this guy, we're looking for two things that multiply to get negative 28, add to get positive 3. So you got 1 plus sun, 1 plus sun. All right. All right, so in that case, that's going to be y plus 7 and y minus 4. All right, and again, you can cancel common factors out. So in this case, we have y plus 7 can cancel out from the top and bottom. So yeah, so we have y plus 10, and then we have y times y minus 4. All right, and again, in this case, we have three factors in the denominator. So again, none of these can equal 0. So in this case, we need to exclude three values. So we have y could equal 0, or I guess could not equal 0. Then we have negative 7 and 4. So again, you just set each factor equal to 0 to figure out the values that you need to exclude. All right. Last one here. So we got negative y squared minus 3y minus 3 equals 0. All right. So yeah, so looking at this, don't think there's any way that we can factor this. So yeah, so again, can use the quadratic formula, so we just need our ABCs. All right, so again, A is going to be whatever your leading coefficient is. So in that case, that's -1. B is going to be your middle coefficient, so -3. And C is going to be your constant term, so -3 again here. All right, so then we have y equals -b, so -3, plus or minus the square root of b squared, so we got -3 squared, minus 4 times a, which is -1, times c, which is -3, all over 2 times a, which is -1 here. So yeah, so we end up with 3 plus or minus, we'd have 9 minus 12, so we got -3 over -2. So we got 3 plus or minus I square root of 3 over -2. So again, we have a negative square root. We can bring an I out front, and then we just make wedges inside that square root of positive. So yeah, so that would be your answers there. All right, so we got 3 plus I square root of 3 over -2. And then 3 minus I square root of 3 over -2. All right. All right. So where do I submit it? Submit. All right. So yeah, so let's go ahead and see how we did here. Uh-oh. All right. Let's go to review here. Ah. Question 1. Started off. All right. Let's see here. I just couldn't read my handwriting. Yeah. All right. So yeah, so again, you'd subtract the 3 from the 11. Yeah. My 11 looked like a 4, so I thought I had a 4 there. All right. Okay. Let's see. Where is the next incorrect one here? All right. So this is question 8. 7, 8. Why would it be -1/7? Oh, I just factored that wrong. Yeah. So yeah, so when I factored this back here, so we have 7x squared plus x. So yeah, so we can factor out an x, but then we're going to have 7x plus 1. So yeah, so then when we set this equal to 0, we'd subtract 1, divide by 7, so we would get -1/7 there. All right. Okay. So it looks like I just messed up my signs there. Ah, I messed up my signs just when I wrote down the question. So yeah, so this should be a plus 21x, which, yeah, would switch these around. And that's where I would switch the signs, yeah. Okay. All right. So yeah, so again, one of the main things is to read the question carefully, which I am as prone to forget that as anybody else. All right, and I think those were the 3 that I missed. Yeah. So yeah, so hopefully you found this helpful. Yeah, I'm planning on doing that for the rest of the exams as well. Just again, in case we don't get all your questions answered during class. So hopefully you found this helpful. Have a lovely day, and I'll talk to you later. Bye now.